हेलो एवरीवन। आज हम लोग देखेंगे डिफरेंशिएशन। सो देखो, हम लोग डिफरेंशिएबिलिटी जो है वो हम लोग अपलोड कर चुके हैं, उसको पहले देख लो, फिर इस डिफरेंशिएशन का वीडियो देख लो। डिफरेंशिएबिलिटी में हम लोग को पता है कि कोई फंक्शन अगर x है, सो डी डी एक्स ऑफ एफ ऑफ एक्स, दैट इज लिमिटिंग वैल्यू ऑफ लिमिट h टेंड्स टू 0 f of x plus h माइनस f of x बाई h। ओके, इसी चीज को हम लोग बोलते हैं डिफरेंशिएशन, राइट, और डेरिवेटिव, दैट इज इसी चीज को हम लोग बोलते हैं f डैश x, राइट। अब हम लोग देख लेते हैं कि यहाँ पे डिफरेंशिएशन का जितना बेसिक फॉर्मूला है, पहले उसको रिवाइज कर लेते हैं। नंबर 1, डी डी एक्स ऑफ x to the power n is n into x to the power n minus 1. Number 2, d dx of e to the power x is e to the power x. Number 3, d dx of a to the power x is a to the power x log of a base e, where we know that a should be greater than 0. Number 4, d dx of log of x is 1 by x. Number 5, d dx of log of x base a is 1 by x log of a base e, where a should be greater than 0 because it is within the log, and a should not be 1 because log of 1 is 0, 1 by 0 is undefined. Now number 6, d dx of sin x is cos x. Number 7, d dx of cos x is minus sin x. Number 8, d dx of tan x is sec square x. Number 9, d dx of cot of x is minus cosec square x. Number 10, d dx of sec x is sec x tan x. Number 11, d dx of cosec x is minus cosec x cot x. Okay, now you have to remember some of the things, that is differentiation of any constant term is 0, right? We know this. And if, let us say, this is number 1, number 2 is d dx of c into f of x is c times d dx of f of x. Okay, c will be outside the derivative because it's constant. We know the product rule, d dx of u into v, where u and v are function of x, is u dv by dx plus keeping v outside du by dx. Okay, you can apply this rule for 4 functions, but in that case you have to, if this is consist of u v w, then you can take u as one function and u and v and w as other functions. Then you have to apply u and v rule for v and w. Now number 4 is ddx of u by v, that is u and v are function of x. This is known as quotient rule. So v square, keeping v constant, keeping v outside, it would be du by dx minus keeping u outside, it will be dv by dx, right? Now let us see some question. Question number 1. If y equals to 1 plus x, 1 plus x square, 1 plus x to the power 4, 1 plus x to the power 8, 1 plus x to the power 2 to the power n, find dy by dx. Let's see the solution. See, here y is this in this format. Let us multiply by 1 minus x and divide by 1 minus x. So it would be 1 plus x, 1 plus x square, 1 plus x to the power 4, it will go in this form, 1 plus x to the power 2 to the power n, by 1 minus x. So 1 minus x into 1 plus x, a plus b into a minus b, that is a square minus b square. Okay, it will be reduced in this form. उसके बाद हम लोग क्या कर सकते हैं, यहाँ पे देखो ये फिर से a माइनस बी ए प्लस बी, so इसका माइनस बी इसका मतलब एक्स टू द 4 होगा. ओके, तो इसका मतलब जो y होगा वो x टू द पावर 2n तक जाते जाते एक्स स्क्वायर है, तो ये हो जा रहा है x टू द पावर 4, राइट. मतलब जो है उसका स्क्वायर हो जाएगा, तो लास्ट में x टू द पावर 2n है तो उसका स्क्वायर हो जाएगा, मतलब x टू द पावर 2n इंटू 2, मतलब x टू द पावर 2n plus 1. So it will be 1 minus x to the power, the last term would be 1 minus x to the power 2 to the power n plus 1. If we break this, it will be 2 to the power n into 2. That means x to the power 2n square, right? By 1 minus x. Now we have to differentiate y with respect to x. So dy by dx would be, this is quotient rule, 1 minus x whole square, 1 minus x को अगर हम लोग बाहर रखें तो अंदर जो है इसका डिफरेंशिएशन हो, 1 का डिफरेंशिएशन 0 होता है, राइट. तो चलो पहले लिख लेते हैं, ddx of 1 minus x to the power 2 to the power n plus 1 माइनस, अब इसको रखेंगे हम लोग 1 minus x to the power 2 to the power n plus 1 into ddx of 1 minus x, राइट. अब इसका डिफरेंशिएशन कर लेते हैं. So it would be 1 minus x and 1 के लिए 0, बाहर माइनस है तो माइनस बैठ जाएगा, एक्स टू द पावर एन, इसको अगर पूरा चीज को अगर एन पकड़े हम लोग तो ये क्या होगा, एक्स टू द पावर एक्स स्क्वायर एन, इसको पूरा अगर एन पकड़े तो ये होगा एन इंटू एक्स टू द पावर एन माइनस वन, दैट इज टू द पावर एन प्लस वन, दिस इज एन इंटू एक्स टू द पावर टू द पावर एन प्लस वन एक्स टू द पावर एन माइनस वन, राइट, प्लस वन माइनस एक्स to the power n plus 1 into ddx of 1 is 0 and ddx of minus x, that is 1 minus 1, so it will be plus divided by 1 minus x whole square, right. Now to simplify, simplification यहाँ पे कर लेते हैं, 1 से अगर मल्टीप्लाई कर दे इसको तो ये हो जाएगा माइनस टू टू द पावर n प्लस वन इंटू एक्स टू द पावर टू 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 द पावर n प्लस वन माइनस वन n plus 1 minus 1 and it would be x to the power 2 to the power n plus 1 और x के साथ x ये जो है ये वाला अगर तुम्हारा मल्टीप्लाई हो जाएगा तो ये वाला क्या हो जाएगा, इस चीज को अगर इस चीज से 1 से मल्टीप्लाई करो तो ये वाला निकला, फिर x को इससे मल्टीप्लाई करेंगे तो क्या निकलेगा, माइनस माइनस प्लस, यहाँ पे x टू द पावर 1 है और यहाँ पे x टू द पावर 2 n प्लस 1 माइनस 1 है तो माइनस 1 प्लस 1, राइट, तो वो वाला माइनस 1 प्लस 1 चला जाएगा, मतलब यही वाला रह जाएगा, तो ये हो जाएगा 2 टू द पावर n प्लस 1 इंटू एक्स टू द पावर 2 n प्लस 1, और फिर जब हम लोग 1 से इसको मल्टीप्लाई करेंगे सो माइनस 1 इंटू 1 दैट विल बी माइनस 1 एंड हियर प्लस 1, सो इट विल कैंसिल आउट, और फिर जब माइनस एक्स इंटू माइनस 1 होगा तो यहाँ पे हो जाएगा प्लस एक्स, राइट, माइनस एक्स इंटू माइनस 1 दैट इज प्लस एक्स, और यहाँ से निकलेगा माइनस एक्स टू द पावर 2 n प्लस 1, so it will be 1 माइनस एक्स, सो 1 से वाला मल्टीप्लाई हुआ तो ये वाला निकला, फिर x से मल्टीप्लाई हुआ तो ये वाला हुआ, फिर 1 इंटू माइनस 1 दैट इज माइनस 1 एंड दिस प्लस 1 विल कैंसिल आउट, फिर x से मल्टीप्लाई होगा यहाँ पे होगा प्लस एक्स, और फिर यहाँ पे बचा माइनस एक्स टू द पावर 2 टू द पावर n प्लस 1 बाई 1 माइनस एक्स होल स्क्वायर, राइट, यहाँ तक हम लोग बोल सकते हैं, तो इसी को हम लोग आंसर मान सकते हैं, ओके। नाउ लेट अस सी आवर नेक्स्ट क्वेश्चन, क्वेश्चन नंबर 2. Question number 2 is, if f of x is equals to mod of cos x minus sin x, find f dashed pi by 6 and f dashed pi by 3, okay. So see the solution. Now see, पहले हम लोग को ये mod ब्रेक करना होगा, right. So f of x equals to mod of cos x minus sin x, this would be cos x minus sin x if x is between 0 to pi by 4, and it will be minus of cos x minus sin x if x is between pi by 4 to pi by 2. See, we know the cosine curve. This is our cosine curve. Okay, this is our cosine curve. This is cos 0 is 1 maximum. Then it is 0. Cos pi by 2 is 0. So this is pi by 2. Okay. Now we know sine curve. This is our sine curve. Sine pi by 2 is maximum. So here it is maximum. Okay. Then sine n pi. So it is pi is 0. Then it will go like this. Right. So it is 2 pi. And cos 2 pi is again maximum. Right. Remember this format because यहाँ से बहुत सारा क्वेश्चन बन सकता है जेई में जेई एडवांस में बोर्ड्स में अगर डिफिकल्ट क्वेश्चन बनाया जाए तो इस ग्राफ से बनाया जाएगा तो ये हो गया तुम्हारा कॉस और साइन कर्व राइट दिस इज योर कोसाइन कर्व एंड दिस इज योर साइन कर्व कि this is your pi by 4 and if x is between 0 to pi by 4 that is this curve cos is bigger than sine right so cos is bigger than sine that means cos x minus sine it will be positive and in between pi by 4 to pi by 2 in between pi by 4 this is a pi by 4 to pi by 2 this is your pi by 2 this is your pi by 2 sorry this is your pi by 2 sin x is maximum sin x is greater than cos x okay so sin x अगर cos x से बड़ा है तो यहाँ से बाहर माइनस निकलेगा तो ये माइनस होगा remember this is very important अब यहाँ पे जब हम लोग का ये ग्राफ एनालिसिस मिल गया मॉड को हम लोग तोड़ लिए इसके बाद हम लोग यहाँ से आगे बढ़ सकते हैं राइट सो यहाँ से हम लोग बोल सकते हैं कि एफ एक्स जो ग्राफ है वो हम लोग का क्या हो गया cos x minus sin x if 0 less than x less than pi by 4 and it would be sin x minus cos x it would be sin x minus cos x if x is between pi by 4 to pi by 2 तो इसका हम लोग f dash निकाल लेते हैं so f dash x would be minus sin x differentiation of cos x minus sin x and differentiation of sin x is cos x minus cos x if x is between 0 to pi by 2 pi by 4 and sin x differentiation is cos x differentiation is minus sin x so it would be plus sin x if x is between pi by 4 to pi by 2 now we have to find the value f dashed pi by 6 and f dashed pi by 3 right so f dashed pi by 6 that is 30 degree so 30 degree lies in this interval and f dash pi by 3 60 degree that is lies in this interval so f dash pi by 6 would be we have to take this function minus sin pi by 6 minus cos pi by 6 this would be minus root 3 plus 1 by 2 okay and please put the values of sin pi by 6 that is half cos pi by 6 is root 3 by 2 right and f dash pi by 3 is now we have to take this function cos of pi by 3 plus sine of pi by 3. So it would be root 3 plus 1 by 2. Okay. Now let's say our next topic. That is differentiation of inverse trigonometric function. Okay. Now before that you have to know some of the formulas of inverse trigonometric function. Okay. So यहाँ पे जो फॉर्मूला यूज होगा मैं अपना लिख देता हूँ. Sin inverse x plus minus sin inverse y. Formula is sin inverse x into root under of 1 minus y square plus minus y into root under 1 minus x square. Then second formula is cos inverse x plus minus cos inverse y equals to cos inverse xy minus plus. If here is plus, there will be minus, and if here is minus, then here will be plus. Root under of 1 minus x square into 1 minus y square. Next formula, tan inverse x plus minus tan inverse y. This is tan inverse of x plus minus y by, if you take plus here, you have to take plus here, by 1 minus plus xy. Okay. If you take plus here, then in the numerator it will be plus, and in the denominator it will be minus. And if you take minus here, then in the numerator would be minus and denominator would be plus. Now और भी जो बेसिक फॉर्मूला है, कुछ फॉर्मूला हम लोग यहाँ पे चाहिए होगा, तो इसका कोई क्विक रिवीजन हम लोग देख लेते हैं. लिमिट x टेंड्स टू a, x to the power n minus a to the power n by x minus a is n into a to the power n minus 1. Limit x tends to 0, sin of x by x is 1. Always remember, यहाँ पे x है तो यहाँ पे x होगा, यहाँ पे ax है तो यहाँ पे ax होगा, यहाँ पे minus x है तो यहाँ पे भी minus x होगा. Right? Remember this formula. This format is extremely important. Similarly, limit x tends to 0, tan x by x, ये होगा 1. Similarly, limit x tends to 0, sin inverse x by x, it would be 1. Similarly, limit x tends to 0, tan inverse x by x, it would be, this is limit x tends to 0, tan inverse of x equals to 1. Tan inverse x by x equals to 1. Now, let's see it. Limit x tends to 0, a to the power x minus 1 by x is log of a base e, where a is greater than 0 and a is not equals to 1. Next is limit x tends to 0, log of 1 plus x by x equals to 1. Next is limit x tends to 0, log of a, log of 1 plus x base a by x. This would be log of e base a. These are the some important formulas and some limits we have learned in the earlier classes. Okay, now let's see some differentiation of inverse trigonometric functions. So ddx of sine inverse x would be 1 by root under 1 minus x square for x belongs to open interval minus 1 to 1. Okay, you have to remember the domains, because whenever there are good questions framed, they will be framed from the domains. Now let's see ddx of cos inverse ddx of cos inverse x. This would be minus 1 by root under 1 minus x square. Okay, and x is belongs to minus 1 to 1. Next formula, ddx of tan inverse x would be 1 by 1 plus x square. Okay, now next formula is ddx of cot inverse x. This would be minus 1 by 1 plus x square. Next formula, ddx of if x ddx of sec inverse x, let us say sec inverse x would be 1 by mod of x root under of x square minus 1, where x is belongs to all real number except minus 1 and plus 1. Remember this. Next inverse differentiation of inverse function is ddx of cosec inverse x. It would be minus 1 by mod of x root under x square minus 1 for all x not equals to plus minus 1. Okay, or you can say in this format also, for all x is belongs to real number except minus 1 and plus 1. Now see, these are the inverse differentiation of inverse functions, and you have to remember all these formulas in order to do differentiations effectively. Now let's see some question. Question number, it would be question number 3. So let's see question number 3. Question number 3 is let us see one question from first principle. If it is in your syllabus, I don't know whether it is in your syllabus or not, but still I am showing you one question. If in case it is in your syllabus, rest of the things you have to do, right? Let's see one question from the first principle. Differentiate e to the power root x with respect to x from first principle. from first principle. Let's see the solution of this. Let f of x is equals to a to the power root x. Then f of x plus h would be e to the power, in place of x you have to put x plus h. Now you have to find out ddx of f of x. Now we know the basic definition of differentiation, that is limit h tends to 0 f of x plus h minus f of x by h, right? So limit h tends to 0 e to the power root under of x plus h minus e to the power of x by h. If you take e to the power root x common, because here limit is h, so it would be e to the power root x into e to the power root h, right? So e to the power root x, if you take common, it would be limit h tends to 0 e to the power root under x plus h. We have taken e to the power root x common, so e to the power root x plus h minus root of x minus 1 by h, right? So it would be e to the power root of x into limit h tends to 0. Now what we know? We know e to the power x minus 1 by x is 1, right? So here in place of x we have this whole term, so you have to make the whole term in the denominator also. So limit h tends to 0 e to the power root under x plus h minus root under of x minus 1 divided by, if we rationalize or multiply by root under of x plus h minus root x in the denominator, then we have to multiply in the numerator also root under x plus h minus root under of x, and here we have one h, so h. Now this would be e to the power root under of x limit let us say, let this term root over x plus h minus root over x is your y. As h tends to 0, so root x minus root x, y tends to 0. So you can say it reduces to limit y tends to 0 e to the power y minus 1 by y, and we know this is 1. So this whole term would be 1. So multiplied by 1 into, now we have to rationalize because we cannot put limit h tends to 0 here. Limit h tends to 0. Limit h tends to 0 because 1 by 0 is infinite. So we have to rationalize this whole thing. If we rationalize this thing, then it would be root under of limit h tends to 0, root under of x plus h minus root over x, root under of x plus h plus root over x by h into root under of x plus h plus root under of x. So it is your a plus b into a minus b, a square minus b square, that is x plus h minus x, that is h by h cancels out, then will will remain with e to the power x into limit h tends to 0 1 by root over of x plus h plus root over of x. If you put h tends to 0, it will be 1 by 2 root x. So answer is e to the power root x by 2 root x. Okay. So this is the example from first principle. So I think you have understood how to solve this from first principle. If it is in your syllabus, then look into it, or otherwise you can skip this part. Okay. Now we are moving forward to our next topic. If we have this is our chain rule. This is our chain rule. Now what is chain rule? If we have two functions, then how to solve? Right? Let us say we want to find the derivative of ddx of f of g of x. Okay. What is the derivative of this thing? The derivative is d of g of x f of g of x derivative of g of x. Okay. Now if we say that, we can conclude that let z equals to f of y, function of y. Z is a function of y, and y is a function of x. Z is a function of y and y is a function of x. And we want to find out dz by dx. Okay, but y is a function of x. So you can write dz by dx as dz by dy multiplied by dy by dx. This is known as chain rule. Okay, this is the simple format of chain rule. Now let's see some question. This is our question number 4. Now we have to find out the differentiation of log of sine of x. Right? We have to find out this differentiation. So how to solve this? We will see the shortcut techniques also, but let us see how to apply chain rule here. Now let us say y equals to log of sine of x. Okay, and let u equals to sine of x. So then it will be y equals to log of u and u equals to sine of x. Then dy by du, here dy by du, log x is 1 by x, so 1 by u, and du by dx would be differentiation of sin x is cos x. Now we want to find out dy by dx. That means dy by du multiplied by du by dx. This is a chain rule, right? So dy by du is 1 by u and du by dx is cos x. And what is u? U is sin x. So it would be cos x by sin x, that is cot x. Okay. Now see how to solve quickly. Let us say y equals to log of sin x. and we are finding out dy by dx. Log of x, let's assume this is x. So what will be the differentiation? 1 by x, that is 1 by sine of x. Now this log function has been done. Now you have to move into this sin x. Differentiation on sin x is cos x. So it will be cot x, right? So with respect to this format, it is very easy. Let's see some other problem. Let us say we have to derive, we have to find the differentiation of sine cube x. Okay. Now let's see the answer. Let y equals to sine cube x. So what would be dy by dx? It would be, पहले हम लोग पावर के लिए करेंगे. So power is 3. So this is in x to the power n format, right? So n into x to the power n minus 1. 3 minus 1 is 2. So it would be sin square x. Now power डिफरेंशिएशन हो चुका है. अब हम लोग अंदर घुसेंगे तो sin x का क्या होगा? cos x. So this is your answer. Okay, that's how we can solve any question quickly. Now let's see next question. Question number 6. That is, we have to find out the differentiation of e to the power x sin x. Now let's assume y equals to e to the power x sin x. Now if we assume that this whole term is x, then what would be the differentiation? E to the power x differentiation is e to the power x, right? Now what will be the differentiation of x sin x, right? एक्सपोनेंशियल का डिफरेंशिएशन हो चुका है, अब अंदर जाना है. अंदर जाके क्या देख रहे हैं हम लोग? x sin x. तो इसको u लेंगे, x को u लेंगे, sin x को p लेंगे. सो x को रखे, sin x का डिफरेंशिएशन क्या होगा? cos x. और sin x को रखे तो x का डिफरेंशिएशन क्या होगा? 1. सो दिस इज योर आंसर. ओके, सो आई थिंक ये जो क्वेश्चन है तुम लोग समझ पा रहे हो. नाउ let us see another question. Let us say we have to find the differentiation of y equals to e to the power of x. Okay. Now see what will be dy by dx. Let us say this whole term is your x. So what would be the differentiation of e to the power x? It would be e to the power x. Now we have to move into this e to the power x. What will be the differentiation of e to the power x? Sorry, it would be e to the power x. And what is the differentiation of x? It is 1. So this is your answer. Now let's say our next question, we have to derive y equals to log of tan of pi by 4 plus x by 2. We have to differentiate this thing. So how to differentiate this thing? Now let us say log of x. Now let us say this whole thing is your x. So what is the differentiation of log of x? That is 1 by x, right? So it would be dy by dx equals to 1 by tan of pi by 4 plus x by 2, right? And what is the differentiation of, now log is performed. Now what is the differentiation of tan of x? That is sec square x. So it would be sec square pi by 4 plus x by 2. Now tan is done. Now I have to move into the brackets. Differentiation of pi by 4 is 0. Differentiation of x by 2. So if we take half outside, dx by dx is 1. So you have to multiply it by half here. right? Now, what will be the differentiation? Let's see. Now, it would be 10 of x is sin x by cos x. So it would be cos of pi by 4 plus x by 2 multiplied by divided by sin of pi by 4 plus x by 2, and sec square pi by 4 plus x by 2 means 1 by cos square pi by 4 plus x by 2 multiplied by half. So this cos 1 cos cancels out. So 2 sin a cos b, that is sin 2 theta. So sin 2 theta, that is pi by 4 plus x by 2. This means 1 by sin of pi by 2 plus x. What is 90 degree plus theta? That is cos theta. So 1 by cos x. That is sec x. So answer is sec x. Okay. So I think this is very easy, right? Now let's say question number 9. Now let us see how to solve this question. Question number 9. If y equals to x plus root under of x square plus s square whole to the power n, then prove that dy by dx is equals to n y root under of x square plus s square. It's a very important question. Now we have to find out the differentiation of this thing. So let us find out by chain rule. So dy by dx would be, so पहले पावर के लिए होगा, this is x to the power n format. So what would be the differentiation? N into x to the power n minus 1. Moving into the bracket, we see x first. So differentiation of x is 1 plus, then we see square root. So we can assume that this thing is whole thing as x to the power half. That is x to the power n format. N into x to the power n minus 1. That is x square plus a square to the power half minus 1. Now we have to move into the square root, that is x square. Okay. Differentiation of x square is 2x. So this would be n into x plus root under of x square plus a square to the power n minus 1 into 1 plus, it would be 1 by root under of x square plus a square. This 2 and 2 cancels out. So this would be x by root under of x square plus a square. Okay. Now let's simplify this thing. Let's LCM this. So n into x plus root under of x square plus a square to the power n minus 1 into root under of x square plus a square plus x by root under of x square plus a square. Now this would be, this is power 1 and this is n minus 1. So if you add, this will be n. So it would be n into x to the power x plus root under of x square plus a square whole to the power n by root under of x square plus a square. Now y is x plus root under x square plus whole to the power n. So this is y. So this would be n into y by root under of x square plus a square. Okay. So I think you got the logic how to solve this type of question. Now let's see another question. Question number 10. Question number 10. If f of x is root under of x square plus 1, g of x is x plus 1 by x square plus 1, and h of x is 2x minus 3, then find f dashed h dashed g dashed x. Okay, you have to find this thing. So it's a very good question. Let's see the solution. Now see our f of x is root under of x square plus 1. G of x is x plus 1 by x square plus 1, and h of x is 2x minus 3. Now what is f dash x? F dash x would be, it would be, see, we can consider x square plus 1 as x. So x to the power n format, x to the power half. So n into x to the power n minus 1, that is half minus 1 is minus half. So it would be 1 by twice root under x square plus 1. Now if you move into the square root, x square, differentiation of x square is 2x, and differentiation of 1 is 0. So these two to cancel out. So this would be x by root under of x square plus 1. Now what would be the differentiation of x, g of x, that is g dash x. Now if we apply u by v rule, then it would be x square plus 1 whole square, keeping x square plus 1, differentiation of x is 1, minus differentiation of 1 is 0, minus keeping x plus 1, derivative of x square plus 1, x square derivative is 2x, and 1 derivative is 0. Okay, so if we simplify, you can see this is minus 2x square plus x square, that means minus x square. This is minus 2x, and this is 1. So 1 minus x square minus 2x by x square plus 1 square. And what is the derivative of hx, that is h dash x, that is 2. Right. Now see, h dash x is 2. Right. So what would be h dash of g dash x? So in place of x, we have to put g dash x. It would be 2 because here there is no x term. Right. Now if we want to find out f dash of h dash g dash x, so what is f of f dash x? F dash x is x by root under of x square plus 1. Right. Now we have to put h dash of g dash of x. What is h dash of g dash of x? This is 2. So in place of x, we have to put 2 here. Right. So this simply means f dash 2. We have to find out f dash 2. Now what is f dash x? This is x by root under of x square plus 1. So put 2 in place of x. It will be 2 by root under of 2 square, that is 4 plus 1. That is 2 by root 5 is the answer. राइट. हमारे क्लास 12 में जितना भी चैप्टर है उसमें डिफरेंशिएशन जो है वो सबसे आसान चैप्टरों में से माना जाता है. ठीक है. नाउ वी हैव सीन द formula of inverse trigonometric function. Now let's see some other problems. Okay. Now see, we'll see some question based on trigonometric substitution. Okay. So before applying trigonometric substitution, let's revise some formulas which will be applied here. So sin 2x is 2 sin x cos x. Next, 1 plus cos 2x is 2 cos square x, or cos 2x cos 2x is 2 cos square x minus 1. Okay, let's give this 1, this 2. Now, number 3, 1 minus cos 2x would be 2 sin square x, or we can say cos 2x is 1 minus 2 sin square x. Next formula, sin 2x is 2 tan x by 1 minus tan square x. Now, sin 3x is 3 sin x minus 4 sin cube x. Now, cos 3x is 4 cos cube x minus 3 cos x. Tan 3x is 3 tan x minus tan cube x by 1 minus 3 tan square x. Right. So these are some basic formulas, and for inverse trigonometric function formula, please go through our inverse trigonometric function lectures. There you will learn all the formulas of inverse trigonometric function, because in this we will apply all the formulas. Now see, here you have to remember, if there is any expression and what you have to substitute. If there is any expression something like this, x square plus x square, then you have to substitute x equals to a tan theta or a cot theta. If there is any expression as a square minus x square, then you have to substitute x equals to a sin theta or a cos theta. If there is any expression as x square minus a square, then you have to substitute x equals to a sec theta or a cosec theta. If expression is looks like this, a minus x by a plus x, or root under of a plus x by a minus x, then you have to substitute x equals to a cos 2 theta. If the expression is a square minus x square by a square plus x square, or root under of a square plus x square by a square minus x square, then you have to put x square as a square cos 2 theta. Remember this substitution. This is way more important. It can save your life. Okay, this is very, very important. Now, let's see some differentiation regarding inverse trigonometric function. This is our question number 11. We have to differentiate with respect to x, that is, find the differentiation of sine inverse of sin x, where x belongs to 0 to 2 pi. Okay. Now, here you have to remember, you need the concept of inverse trigonometric function. Here we know that first of all, let y equals to sine inverse of sin x. Then it would be sine inverse and sine will go out. It will be x if x belongs to 0 to pi by 2. It will be pi minus x if x belongs to pi by 2 to 3 pi by 2. It will be minus 2 pi plus x if x belongs to 3 pi by 2 to 2 pi, because our whole interval is 0 to 2 pi, so you have to break 0 to 2 pi in this format. If it is 0 to 2 pi, then it will be x. If it is pi by 2 to 3 pi by 2, then it will be pi minus x. And if it is 3 pi by 2 to 2 pi, then it will be minus 2 pi plus x. You have to remember this, otherwise the differentiation would be very difficult. You have to differentiate y with respect to x. Now see, let us first check if within these intervals, if the differentiation is possible or not. Now see, left hand derivative at x equals to pi by 2 is 1. Okay. And if you want to find out left hand derivative, then if you are not getting how it came as 1, then go through our differentiability chapter. There, differentiability, how to find out left hand derivative and right hand derivative, we have discussed very well. Okay. So, and if you find out right hand derivative at x equals to pi by 2, right hand derivative means that x equals to x tends to pi plus, from you have to take pi minus x, and left hand derivative means pi minus, that is you have to take this function. Okay, you will see this will come out as minus 1. Okay, left hand derivative will come out as, at pi by 2 it will come out as plus 1, and at right hand derivative at pi by 2 will come out as minus 1. And if we check left hand derivative at x equals to, we have checked at pi by 2, now we are checking at 3 pi by 2. So if we check this as 3 pi by 2, it will be, you will get minus 1. And if you check right hand derivative at x equals to 3 pi by 2, you will get it as 1. I am again telling, if you are not getting how this is coming, we are not showing here, because it will be, this lecture will be bulky, so we are omitting the derivative test. differentiability check. Find out this on your own. Okay, so let's move out. So you can see here left hand derivative is +1 and right hand derivative is -1 at pi by 2. So this is not differentiable. Not differentiable at x equals to pi by 2. And it is also not differentiable at x equals to 3 pi by 2. Okay. So if we find out dy by dx here from this function, then it will be x differentiation is 1 if x belongs to 0 to pi by 2, and we have to give open interval here because at pi by 2 it is not differentiable, right? At pi by 2 it is not differentiable, and pi differentiation is 0 minus x is -1 when x belongs to it is not differentiable at pi by 2, so here it will be open interval, and it is not differentiable at 3 pi by 2 also, and not differentiable at 3 pi by 2. Differentiation of -2 pi is 0 and differentiation of x is 1 when x belongs to 3 pi by 2 comma 2 pi. Here you will have close interval. Okay, this is how you have to find the differentiation of this thing in this format. Okay, so please go through our inverse trigonometric lecture where you will find out all these formulas, how we come into conclusion in this format. You will get it here, you will get it there. Okay, now let's see our next question, that is question number 12. Differentiate cos inverse of 2x square minus 1 with respect to x if number 1 x is between 0 to 1, number 2 x is between -1 to 0. Let's see the solution of this type, how to differentiate this thing. Let y equals to cos inverse 2x square minus 1. Okay, now let's put x equals to cos theta. So you'll get 2 cos square theta minus 1. So you'll get cos inverse 2 cos square theta minus 1. Now we know 2 cos square theta minus 1 is cos 2 theta. So it will be cos inverse of cos 2 theta. Now our number 1 question is x is between 0 to 1. Okay. Now x is cos theta, right? X is cos theta. This implies we know cos theta varies from 0 to 1. So cos theta varies from 0 to 1. So theta will vary. X is cos theta, right? X is cos theta. X varies from 0 to 1. So that means cos theta will vary from 0 to 1. Now what would be theta? Theta would be cos inverse 0, cos inverse 1. Cos inverse 0 is 0. So 0 to theta less than cos inverse 1 is pi by 2. So it will be pi by 2. Okay. If you multiply it by 2, then you will get 0 less than 2 theta less than pi. So 2 theta lies between 0 to pi. Okay. 2 theta lies between 0 to pi. So you can clearly say y equals to cos inverse cos of 2 theta. So it will be 2 theta. That means 2 cos inverse x. Now, what is the differentiation? dy by dx twice differentiation of cos inverse x minus 1 by root under of 1 minus x square. Now, number 2 question is x varies from minus 1 to 0. Minus 1 to 0. Now, let's solve this. We know x is cos theta. This implies x is minus 1 to 0. That means cos theta will vary from minus 1 to 0. Now, if you take inverse cos inverse of minus 1, that is pi by 2, cos inverse of zero, it will be if you take cos inverse of 0, this would be pi by 2, and cos inverse of minus 1, it will be pi. I'm extremely sorry, because we know cos n pi is minus 1 to the power. If you take 1, that is cos pi, it will be minus 1 to the power 1, that is minus 1. So it will vary from pi to, it will vary from pi to, it will vary from pi to pi by 2. So it doesn't make sense, right? So we can say theta varies from pi by 2 to pi. If you multiply by 2, you will get pi less than 2 theta less than 2 pi. So theta varies from pi to 2 pi. Now our y is cos inverse of cos 2 theta. Now we know that here 2 theta varies from pi to 2 pi. So we can say 0 less than 2 pi minus 2 theta less than pi. Okay. So in place of 2 theta, we can say it is 2 pi minus 2 theta. Because within this interval, cos theta is cos inverse cos theta is theta. So y would be cos inverse cos of 2 pi minus 2 theta. So it would be 2 pi minus 2 theta. So 2 pi minus twice theta is cos inverse x. So twice 2 pi minus 2 cos inverse x. Now if you differentiate dy by dx would be 2 pi differentiation is 0. Differentiation of cos inverse x is 1 by root under 1 minus x square, that is plus 2 by root under 1 minus x square. So it would be 2 by root under 1 minus x square. Okay. Now between 0 to pi cos inverse theta, cos inverse cos theta is theta. Okay. Here see, here also we have use the same logic. Between 0 to pi cos inverse cos theta is theta. That's why we converted 2 theta into 2 pi minus 2 theta. Okay. Because our 2 theta ranges from pi to 2 pi, we have to convert it into 0 to 2 pi. So first of all, multiply minus 1 in all the sides. So this less than sign will be greater than sign, this will be greater than sign, and here will be minus 2 pi, here will be minus pi. Now if you add 2 pi in all the sides, then minus pi plus 2 pi would be plus pi, and 2 pi minus 2 pi plus 2 pi would be 0. So 0 is here, and 2 pi minus pi is pi, and this pi is here, and this will be 2 pi minus 2 theta. So 2 pi minus 2 theta actually varies from 0 to pi. So in place of 2 theta, we can say it is 2 pi minus 2 theta. So I think ये जो इनवर्स ट्रिगोनोमेट्रिक फंक्शन का जो लॉजिक है, ये तुम लोगों को समझ में आ गया होगा, ठीक है? क्योंकि इसका जो डोमेन रहता है, सारा खेल यहाँ पे इसका डोमेन का होता है. If you don't know the domains of differentiation and the formulas of inverse trigonometric function, then there is less chance that you can solve any question which will come from your differentiation chapter. Now let's see our next question. 13. We will cover this topic more elaborately in our JEE and JEE advanced classes. So wait for the videos to upload. We will definitely upload the complex problems and logics which will come in your JEE or JEE advanced. Okay, but for board level, I think this is sufficient. Now we have to differentiate tan inverse x, tan inverse of root under 1 plus x square minus 1 by x, where x is not equals to 0. We have to differentiate this. So let's see the differentiation. Now see, let y is equal to tan inverse of root under 1 plus x square minus 1 by x. Okay. Now we know if it is in the format 1 plus x square. Okay. We have seen these formats, right? We have seen this format. If it is in the format a square plus x square, then you have to take a tan theta. So here also you can see there is a format 1 plus x square plus x square, 1 square plus x square. That means you have to take it as a tan theta, that is 1 tan theta. So put x equals to tan of theta. So we get tan inverse 1 plus tan square theta, that is sec square theta, square and square root will cancel out. You will get sec theta minus 1 by tan theta. Now breaking into sin cos, it will be 1 by cos. So 1 minus cos theta by cos theta, and from tan theta you will get sin theta by cos theta will cancel out. You will get tan inverse of 1 minus cos theta by sin of theta. 1 minus cos 2 theta is 2 sin square theta. So here theta is there. So our formula will be 2 sin square theta by 2. So tan square 2 sin square theta by 2 by sin 2 theta is 2 sin theta cos theta. Here theta is there. So in our formula we will get theta by 2. So 2 sin theta by 2 cos theta by 2. Okay. So this two will to cancel out, sine, one sine will cancel out, sine theta by 2 by cos theta by 2, that is tan theta by 2. So tan inverse tan theta by 2, you will get theta by 2 because there is no domain given. It is given that x not equals to 0 for this, but nothing is mentioned. So you can say tan inverse tan theta by 2 is theta by 2. So it will be half tan inverse of x. And we know if we differentiate now on the both sides, we will get half differentiation of tan inverse x is 1 by 1 plus x square. Okay, now it is very easy. So remember this trigonometric substitution is extremely important. First of all, what you have to do, you have to simplify uh, the expression that is given, only move forward, then only move forward to solve that question. Otherwise, it will be very difficult to solve. Let's see next question. 14th number question. If y equals to tan inverse root under 1 plus x square plus root under 1 minus x square by 1 plus x square minus 1 minus x square. Given that minus 1 less than x less than 1, x is not equals to 0, find dy by dx. Okay, you have to find. So let's see. Here 1 plus x square 1 minus x square. The question is given in this format. Okay. So here question is given in this format. So in place of x square, we will get a square cos 2 theta. Okay. So a is 1. So we will get cos 2 theta. Remember the format. So let x square is cos 2 theta. So our y will be tan inverse of square root 1 plus cos 2 theta plus square root 1 minus cos 2 theta by square root 1 plus cos 2 theta minus square root 1 minus cos 2 theta. So it will be tan inverse 1 plus cos 2 theta is 2 cos square theta. So you will get 2 cos square theta. 1 minus cos 2 theta is 2 sin square theta. So you will get 2 sin square theta by, here you will get 2 cos square theta. Here you will get 2 sin square theta. Root 2, if we take root 2 common from numerator and denominator, it will cancel out. Square root of cos square theta is cos theta, square root of sin square theta is sin theta. So we get tan inverse cos theta plus sin theta by cos theta minus sin theta. If you divide by sin theta, you will get, if you divide by sin theta in numerator and denominator, you will get sin theta by sin theta, that is 1, cos theta by sin theta, that is cot theta, but sorry, we have to divide by cos theta in the denominator. Cos theta by cos theta is 1 and sin theta by cos theta is tan theta. By cos theta by cos theta is 1 and sin theta by cos theta, that is tan theta. Right? Now, this is in the format tan A plus tan B divided 1 minus tan A tan B. Let's write it down. In place of 1, we can write tan pi by 4. This is tan theta. This is 1 minus tan pi by 4 is 1 into tan theta. This is in the format tan A plus tan B divided by 1 minus tan A tan B. So you'll get tan inverse of 1 plus tan inverse of tan theta, right? So our slide is hanging. It will be tan inverse of tan of A plus B. Tan inverse of tan theta is theta. So we can say this is pi by 4 plus theta. See, x is minus 1 to 0. So you can say x is minus 1 to 0. So you can say x square will lie between 0 to 1, right? Now x square is cos 2 theta. So cos 2 theta lies between 0 to 1. What is cos inverse 0? That is 1. What is cos inverse 1? That is pi by 2. So 0 less than 2 theta less than pi by 2. If you divide by 2, you will get 0 less than theta less than pi by 4. If you add pi by 4 in both the sides, so you will get pi by 4 less than theta plus pi by 4 less than pi by 4 plus pi by 4, that is pi by 2. So our theta plus pi by 4 lies between pi by 4 to pi by 2. So you can say in this domain tan inverse tan theta is theta. So pi by 4 plus theta. Otherwise it will change. So we can say y equals to pi by 4 plus this theta, x square equals to cos theta, that is cos 2 theta, that is theta would be half of cos inverse x. So half of cos inverse x square. Now you have to differentiate dy by dx. That would be dy by dx of pi by 4, that is 0. That half will come out. And cos inverse x square is minus 1 by root under of 1 minus x square. So x square square, this x to the power 4. Now differentiation of x square is 2x. So it will be, this 2 will cancel out. This will be minus x by root under of 1 minus x to the power 4. That's how you have to use trigonometric substitution and the domains of inverse trigonometric function, because it is very important as far as your examination is concerned. Okay, this is very important question. Now if we move forward to our next topic, then remember this dy by dx, we can write it as 1 by dx by dy. Now our next topic is differentiation of implicit function. Differentiation of implicit function. That means if you have, let us say, if you have a function of x and y equals to 0 and y is a function of x, y is, let us say, y is some function of x. Okay, and then we are finding dy by dx. In such case, okay, and here this function is not separable. That means you cannot separate x and y is a function of x. Then y is said to be an implicit function of x. In that case, if you want to find out dy by dx, then you can write it as d phi by dy into dy by dx. Okay, let's see example. Let us say we want to find out d dx of y square. Okay, so y is a function of x. So that means for square it will be 2y and for y it will be dy by dx. That's how it works. We have covered differentiation of implicit function in a separate video. Please go through it. Okay, we'll solve one problem to revise the concept, but please go through our video of differentiation of implicit function. Let's see one question. Let's say this is our question number 15. 15. If y equals to b tan inverse x by a plus tan inverse y by x, find dy by dx. See here we have y equals to b tan inverse of this thing. So y by b would be tan inverse of x by a plus tan inverse of y by x. So tan of y by b would be x by a plus tan inverse of y by x. Now we have to differentiate both sides with respect to x. See here y is a function of x. So it is in the form implicit function, right? So tan of x differentiation is sec square x. So you will get sec square y by b. If you move into the bracket, then 1 by b will come out as it is a constant. Differentiation of y is dy by dx. 1 by a is a constant. Differentiation of x is 1. And tan inverse x, differentiation of tan inverse x is 1 by 1 plus x square. That is 1 by 1 plus y by x whole square. Now you have to differentiate y by x, so you can apply u by v rule here. So x square x dy by dx minus y into differentiation of x is 1. So you got 1 by b sec square y by b into dy by dx is equals to 1 by a plus x dy by dx minus y by if you LCM do LCM here, so it will be x square plus y square, and this x square and x square will cancel out. You get in this format. So you take this whole term on the left hand side, and if you take dy by dx common, you will get this is x dy by dx by x square plus y square minus y by x square plus y square. And if you take this term in the left hand side and taking common of dy by dx, you will get dy by dx of 1 by b sec square y by b minus x by x square plus y square equals to 1 by a minus y by x square plus y square. Now, what will be your dy by dx? It will be 1 by a minus y by x square plus y square by 1 by b sec square y by b minus x by x square plus y square. Okay. Now, moving forward to our next topic, that is logarithmic differentiation. Logarithmic differentiation. So, where to apply logarithm? If you have y in this format, f of x to the power g of x, function to the power function, then apply log in both the sides. Okay. Let's see some question. So it will be our question number 16. Let us say y is x to the power sin x. This is function to the power function. So take log in both the terms, both the sides. So you will get log of y equals to log of x to the power sin x. This sin x will come out, so it will be sin x into log of x. Now, if you take sin x as u and log x as v, this is differentiation of implicit function, right? So log of y, differentiation of log of y is 1 by y, differentiation of y is dy by dx. This is u, this is v. So if we take sin x, if we keep sin x, and differentiation of log x is 1 by x, plus if we keep log x, differentiation of sin x is cos x. So dy by dx is y. Y cross multiply. Y is x to the power sin x. This is sin x by x plus cos x log x. This is the answer. Okay. So whenever you see function to the power function, you have to take log on both the sides. Here all the problems are in the same format. Okay, so let's see one problem. 17. If x to the power y is equals to e to the power x minus y, prove that dy by dx is equals to log of x by 1 plus log of x whole square. Okay, now here we can see that it is function to the power function, so you have to apply log on both the sides. So apply log. So log of x to the power y is equals to log of e to the power x minus y. So this implies y log of x. This x minus will come out. X minus y into log of e by c, that is 1. Now what you can do, take y on one side. So y log x plus y equals to x. Take y common, so y would be x by 1 plus log of x. Now if we apply differentiation, dy by dx, apply u by v rule, so 1 plus log of x whole square, 1 plus log of x, differentiation of x is 1 minus x into differentiation 1 is 0, log differentiation of log x is 1 by x. So 1 by x, this will cancel out. So here minus 1, here plus 1, it will cancel out. Log x by 1 plus log x whole square. This is your answer. This is a proof. Okay, so all this type of problem have the same format. If you see function to the power function, the first thing you have to do, you have to take logarithm on both the sides. Then it will be very easy. Either apply u by v rule or apply u into v rule according to your necessity. Now let us move forward to our next topic. Differentiation of infinite series. Differentiation of infinite series. Okay. Now, what logic we have to apply? Let us see some question. Let us say question number 18. If y equals to x to the power x to the power x to the power x is infinity, find dy by dx. ओके, सो यहाँ पे क्या लॉजिक लगाना है कि देखो, एक समंदर से अगर एक बाल्टी पानी ले लोगे तो समंदर का पानी का जो लेवल है वो घटता नहीं है, राइट। तो यहाँ पे हम लोग ये काम कर सकते हैं कि y इक्वल्स टू एक्स, एक एक्स को अगर छोड़ दे तो बाकी ये पूरा चीज सेम ही, हम लोग इसको y बोल सकते हैं. So it will be x to the power y. See, this is in the form function to the power function. So we have to take logarithm both the sides. So log of y equals to log of x to the power y. It will be y log of x. Now differentiate both the sides. You will get 1 by y. For y it will be dy by dx. For y it will be dy by dx, keeping log x outside. And if we keep y outside, differentiation of log x is 1 by x. Differentiation of x is 1. So if we take this term in the left hand side and take common dy by dx, we'll get dy by dx into 1 by y minus log of x is y by x. So dy by dx would be, if you take LCM and cross multiply, this will be y square by x into 1 x minus log x. Sorry, 1 minus y log x. Okay, it's hanging again. 1 minus y log x. Here, all the questions are in the same format. We see another question. Let us say question number 19. Here we have, if y equals to x plus 1 by x plus 1 by x plus 1 by x plus this format. Prove that dy by dx is y by 2y minus x. Again the same logic. If we take one bucket of water, the level of C doesn't change, right? So y equals to x plus, we can say this whole thing as y. So x plus 1 by y. If we take LCM, it will be y square equals to xy plus 1. And if we do differentiation on both the sides, it will be 2y into dy by dx equals to, if you have to apply u into v rule, so it will be y. If you take y, differentiation of x would be 1 plus x differentiation of y would be dy by dx, and differentiation of 1 is 0. If you take this in the left hand side and take common, you will get dy by dx into 2y minus x, that would be y. So this means dy by dx is y by 2y minus x. Okay. Now let's see our next format, that is differentiation of parametric function. Differentiation of parametric function. We are going with the same color because the slide is going long and the page is hanging. Okay. So parametric form. What is parametric form? Let us say, let us understand with this example, with one example. This is our question number 20. If x is a cos t plus half of log of tan square t by 2, and y is a sin t, find dy by dx. See, here x is a function of t, y is a function of t, but you have to differentiate y with respect to x. This form is known as parametric form. Okay. So what we have to do? First of all, let us see if we can minimize this expression. X equals to a into cos of t plus half of twice log of tan of t by 2, and here y is a sine of t. These two will cancel out. So x is a cos of t plus log of tan of t by 2, and y is a sine t. Now if we differentiate both the sides with respect to t first, so dx by dt, it would be a differentiation of cos t is minus sine t, differentiation of log x is 1 by x, differentiation of tan x is sec square x, differentiation of t by 2 is half, and dy by dx, this is a sine t is cos t. So dy by dt, sorry, this is dy by dt. So dx by dt is a minus sine t plus, this is 1 by cos square t by 2, and this is sine t by 2 by cos t by 2. So cos t by 2 and 1 cos t by 2 will cancel out to 2 sine t by 2 cos t by 2, that is sine 2 theta, right? So 2 sine t by 2 cos t by 2, and dy by dt is a cos of t. Okay. Now let's move forward. It will be sine t, right? So dx by dt is a minus sine t plus 1 by sine t, and dy by dt is a cos t. So dx by dt is a, if we take LCM, minus sine square t plus 1 by sine of t, and dy by dt is a cos of t. Now 1 minus sine square theta is cos square theta, right? So dx by dt is a cos square t by sine t, and dy by dt is a cos of t. Now we have to find out dy by dx. So dy by dx would be dy by dt by dx by dt. So dy by dt is a cos t, and dx by dt is a cos square t by sine t. So sine t will be in the numerator. So sine t by cos t, that is tan t, is the differentiation. ओके, तो मुझे लगता है कि जो पैरामीट्रिक फॉर्म है ये समझ में आ गया होगा. यहाँ पे जो क्वेश्चन होता है ना, ये सारा सेम टाइप का क्वेश्चन होता है. नाउ लेट्स मूव फॉरवर्ड टू आवर नेक्स्ट टॉपिक, that is differentiation of a function with respect to another function. Okay, let we have a function u, which is a function of x, and we have a function of v, which is a function of x. Let us say this is g of x, and we want to find out du by dv. Okay, so what we can do, we can differentiate u with respect to x and v with respect to x. So we can say this is du by dx by dv by dx. That's how we can solve this type of format. Let's see one question. If x belongs to 1 by root 2 to 1, differentiate tan inverse root under 1 minus x square by x with respect to cos inverse twice x 1 minus x square. Okay, so you have to differentiate this function with respect to this function. Now you know the process. Let's apply the process. Let u equals to tan inverse square root 1 minus x square by x, and b equals to cos inverse 2x 1 minus x square. Let x equals to sin theta. We know why we have taken sin theta, because 1 minus sin square theta is cos theta. Cos square theta and cos root and square root will cancel out. And we have already discussed x square minus x square. If there is x square minus x square format, what we have to take? Now let x equals to sin theta. So we can say that, see, our x varies from 1 by root 2 to 1. So sin theta will, x varies from 1 by root 2 to 1. That means sin theta varies from 1 by root 2 to 1. If you take inverse, sin inverse 1 by root 2, that is pi by 4 less than theta less than pi by 2. Sin inverse 1 is pi by 2. So theta varies from pi by 4 to pi by 2. Right. Now our u is tan inverse square root 1 minus x square by x. Right. So this is tan inverse square root 1 minus sin square theta by sine of theta. So this would be cos theta, 1 minus sin square theta, cos square theta, square and square root cancel out, cos theta by sin theta, that is cot theta. Right? So this would be tan inverse cot of theta. Now see, theta varies from pi by 4 to pi by 2. So we can say minus theta varies from minus pi by 2 to minus pi by 4. And if we add pi by 2 on both the sides, so it will be 0 less than pi by 2 minus theta less than pi by 4. So we can say that we can convert it as tan inverse tan of pi by 2 minus theta. So it is between 0 to pi by 4, we can write cot theta as tan of pi by 2 minus theta, and just now we have seen that pi by 2 minus theta lies between 0 to pi by 4. So in 0 to pi by 4, tan inverse tan theta will be theta. So our u is pi by 2 minus theta. Now if we differentiate with respect to x, so du by dx would be pi by 2 is 0. It would be pi by 2, and what is theta? Theta is sin inverse x. So what is the differentiation of sin inverse x? 1 by, this by minus 1 by, here minus 1 minus x square. Okay. Now our v is cos inverse 2x root under 1 minus x square. Now we can say, we know that sin inverse x plus cos inverse x is pi by 2. So in place of cos inverse x, we can write pi by 2 minus sin inverse x. So pi by 2 minus sin inverse of 2x square root of 1 minus x square. So it will be pi by 2 minus, and x is sin theta. 1 minus sin square theta is cos square theta. So here we will get cos theta, and it is here we have sin theta. 2 sin theta cos theta is sin 2 theta, and sin inverse sin 2 theta. So we got sin inverse sin 2 theta, right? Again, we can say that we have seen that theta lies between pi by 4 to pi by 2. So minus 2 theta will lie between, if you multiply by minus, this will be greater than and this will be greater than, and 2, that is minus pi by 2, and this will be pi. So minus pi 2 minus pi by 2. If you add pi in all the such, this will be 0, less than pi minus 2 theta, less than pi by 2, right? Now sin inverse sin of 2 theta, here we can write as pi by 2 minus sin inverse sin of pi minus 2 theta, because our, we know if it is between minus pi by 2 to pi by 2, then sin inverse sin theta is theta. So pi minus 2 theta lies between 0 to pi by 2. So you can say this is pi by 2 minus, this is sin inverse pi minus 2 theta, right? So you got minus pi by 2 plus 2 theta. So minus pi by 2 plus 2 sin inverse x. So what is the differentiation? dv by dx is minus pi by 2 is 0. This is twice root under 1 minus x square. Now we need to find out du by dv, right? That's all we have to find out. So we can write du by dx by dv by dx. It will be minus 1 by root under 1 minus x square by 2 by root under 1 minus x square. So it would be, this will cancel out, minus half. Let's see our last type, that is differentiation of determinants. See, what you have to do if your del is a function of x and it is, let us say, f of x, g of x, u of x, and b of x, then if you are differentiating this with respect to x, you can do it by either row wise or column wise. So if you do in the row wise, then do in the first row first, keeping second row as it is, plus keeping first row as it is and differentiating second row. Or you can do in the column wise also. So first column will be derived first, keeping second column, plus keeping first column as it is, differentiating second column. Okay, so let's see one question regarding this. If y equals to f of x, g of x, h of x, L, M, N, A, B, C, prove that dy by dx is f dash x, g dash x, h dash x, L, M, N, A, B, C. You have to prove this. Now see here, y is this, right? Y is determinant of this. Now how do we know? We know that in order to differentiate, you have to keep, you have to do it by through any row or through any column, right? So let us say we are doing with the first row. So if we differentiate it with the first row, differentiation of fx is f dash x, gx is g dash x, and hx is h dash x, and keeping all other terms as it is, plus keeping first row as it is, fx, gx, h of x, and differentiation of second row, that is 0 because all of them are constant, a, b, c, plus keeping first two row as it is, fx, g of x, h of x, L, M, N, and differentiation of ABC, that is 0, 0, 0. We know if in any determinant one row or one column is 0, then whole determinant is 0. That means this comes out to be 0 and this comes out to be 0. So our answer is dy by dx f dash x, g dash x, h dash x, L, M, N, A, B, C. That's all we have to prove. Okay. Thank you and have a good day.